In this video, you'll be given the opportunity to assess your understanding of the learning objectives from the lessons on graphing quadratic functions. I'll also provide you with multiple opportunities to practice questions like you'll see in your next checkpoint quiz. Along with each question, you'll practice it under a certain time constraint similar to what you'll experience on the next checkpoint quiz. Please start by writing down this problem. Writing down this function. So I'm going to ask two questions that are going to correspond, are going to refer back to this function. Each one again will be timed. So you're going to have 15 seconds on paper to identify the end behavior. Begin. And stop. How do you easily figure out the end behavior? The number in front tells us whether the parabola will open up or down. Again, we know that this function is going to model a parabola shape because it is a quadratic. So here we have a parabola that opens downward. Here's just a simple shape of a parabola that opens down. End behavior. As I go to the far left, it's headed down. As I go to the far right, it's also headed down. Next thing, what is the equation of the line of symmetry? You have 15 seconds. Begin. And stop. So as you recall from our teachings, again, well, there's other videos you can go back and refer to, our vertex can be pulled from here. It's opposite of this. So if you take this inside and you set it equal to 0, you come up with an answer of x equals 3. So x equals positive 3 and y equals 7. So that is your vertex. And remember, your line of symmetry always goes through the vertex. So x equals 3 is the equation for the line of symmetry, also known as the axis of symmetry. Just writing 3 or y equals 3 would be wrong. It cuts through the x-axis. If someone asked you to identify the vertex, vertex would be positive 3, positive 7. And now the next one, you're going to have 30 seconds to identify what are the x-intercepts of this graph. What are the x-intercepts of this graph? Again, if you have forgotten to write down the function, this is the function. Okay, x-intercepts, and 30 seconds, begin. And bringing it back here. So we're asked to find x-intercepts. As you recall, to find x-intercepts, the y is always 0. So if we know that our function is headed downward, and this is the vertex, I know there's going to be 2 x-intercepts. Let's find the exact answers. With x-intercepts, y is always 0. So I'm going to substitute 0 in for y, and now I'm going to do simple algebra. Start by subtracting 7 to the opposite side, dividing by a -2. 2 negatives make a positive. How do you get rid of the square? Okay, this tells us we're going to have two answers, so I square root both sides, and the plus or minus goes in front of the opposite side. 7/2 is not a perfect square, so it's an irrational number. I can't take the square root of it without estimating. And now the last step is add 3 to the opposite side. So the exact x-intercepts would be 3 plus square root of 7/2, comma 0, and 3 minus square root of 7/2, comma 0. Okay, your next question is, what is the y? What is the y-intercept of this graph? As a reminder, it's y equals -2 times the quantity x minus 3 squared plus 7. What is the y-intercept? Okay, and you have 15 seconds. Begin. So how do we determine the y-intercept? Okay, with y-intercepts, your x value is always equal to 0, so I'm going to substitute in 0. 0 minus 3 is -3. -3 squared is 9. -2 times +9 is -18, plus 7 is -11. Let's go back to what we know about this graph. 1, 2, 3. We're up 7. Excuse me, we're not up 7 here. -11, up 7 here, and -11 is our y-intercept. And so we're going something like this is a very rough estimate of what this graph looks like. All right, so those are all in factored form. Let's look at something that's, excuse me, those are all in vertex form. Let's look at something that's in factored form. Okay, first one is let's identify the x-intercepts of this graph. You have 10 seconds. X-intercepts of this graph or of this function. 10 seconds, begin. Okay, how do we find them out? Well, the good thing about factored form is we can easily identify the x-intercepts. X minus 5 equals to 0, and x plus 1 set equal to 0. Add 5 to the other side, subtract 1 to the other side. 5, 0, and -1, 0 would be your x-intercepts. What is the y-intercept? What is the y-intercept? As you remember, with quadratic functions are parabolas that open up and down. With quadratic functions, every quadratic function has one y-intercept. Not 0, not 2, not 3. Every quadratic function has a parabola that opens up or down. Quadratic functions are parabolas that open down, up and down, has one y-intercept. How many x-intercepts do they have? This is also known as real roots. How many x? 0, 1, or 2. 0, 1, or 2. Always 1, 0, 1, or 2. In this case, we had 2 x-intercepts. Okay, y-intercept, you have 10 seconds, begin. All right, so the y-intercept, for y-intercepts, the x values are always 0. So I'm going to substitute 0 into each one of the x's. And I have y equals -3. 0 minus 5 is -5. And 0 plus 1 is 1. -3 times -5 times 1 is +15. All right, your next problem. Okay, let's go back to vertex form. Let's write y equals, please write this down, y equals, let's go +3 x plus 1 quantity squared minus 6. For this problem, you are going to have 20 seconds to identify the increasing interval in 20 seconds. begin. Okay, and stop. How can we quickly do this? Well, I'm just going to do a really rough sketch. I know this parabola is going to open upward. I know it has a vertex of -1, -6. -1, -6, and opens upward. Okay, so where is it increasing? Well, from left to right, I'm going down, decreasing, and then going up. Remember, all intervals that increase and decrease use parentheses, and we only describe them in terms of x values. So it starts at -1, and it continues to increase to the right. Okay, next problem. Y equals -1/2 x minus 7 quantity squared plus 4. Y equals -1/2 times quantity x minus 7 squared plus 4. Identify the decreasing interval. You have 20 seconds. Same concept as we did with the last problem. Excuse me. Same concept as we did with the last problem. I'm going to do a quick sketch. Okay, I have a parabola. It opens downward since this number out front is negative. Vertex of +7, +4. So +7, +4 is here, and it's opening downward. +7, +4. So from left to right, I'm increasing, and then I'm decreasing. Remember, we only use parentheses. I'm going to decrease starting at this number. Anything to the right of this is decreasing. So the x value is 7. Now this is where a lot of mistakes are made. Students want to write negative infinity because they see it going downward. But in terms of x values, you're continuing to move to the right, which is written as a positive infinity. Next problem. Let's go back here to y equals standard form. Y equals 3x squared minus 7x plus 4. Okay, in standard form, you have 5 seconds to identify the domain of this function. 5 seconds to identify the domain of this function. Okay, and stop. How can we do this so quickly? The degree, which is the highest exponent, is a 2. That tells you it's a quadratic equation. Okay, quadratic equation. Because the number out front, we have a +3. I know that this is a quadratic function that opens upward. So, with that being said, we've learned that all quadratic functions, which is parabolas opening up and down, all have a domain of -infinity to positive, parentheses on both ends. Parentheses on both ends. Okay, let's do another one. Let's go back right now to, let's go to factored form. Y equals -3, x plus 4, x minus 6. You have 15 seconds to determine the equation of the line of symmetry. 15 seconds to determine the equation of the line of symmetry. Okay. How can we quickly do that? Well, the nice thing about factored form is we can quickly identify the X-intercepts. One is -4, one is +6. Now, the axis of symmetry will fall directly in between these two. So here's visually how we can quickly go to find the axis of symmetry. All right, we can go in one, in one, in one, in one, in one, and it falls on the equation x equals 1. Okay, x equals 1 is where it lies on. All right, your next one is, what is the vertex? What is the vertex of this function? It's in standard form. Y equals x squared plus 7x plus 12. What is the vertex? What is the vertex? You have 40 seconds. Begin. Okay, so how do we find the vertex? Well, the vertex is an x and y coordinate. It's harder to find in standard form. We need to know the equation x equals negative b over 2a. In this case, your a is 1, your b is 7, and your c is 12. So I'm going to substitute 7 in here. X equals negative 7 over 2 times 1, which is 2. X equals negative 7 halves. Okay, that is your x coordinate. That's your x coordinate. Now I need to find the y coordinate. By the way, you're welcome to turn this into a decimal. So to find the y coordinate of the vertex, I take this value, and I prefer it as a decimal, and I substitute in wherever I see an x. Y equals negative 3 halves, and you're not even required to write this down. I'm just doing it so that you can visually see what I'm doing. I'm going to grab a calculator and let the calculator do the hard work. So parentheses, negative 3.5 quantity squared, plus 7 times the quantity negative 3.5 plus 12. Negative 1/4, also negative 0.25. Okay, this is your vertex.